we're going to do the 2 nitrations of bromobenzene, both in the ortho and para position. There's a couple of things we're going to pre-weigh right now, and then we'll move over to the apparatus. The one thing about the bromobenzene is it's a rather thick, syrupy type solvent. And if you measure just 2 milliliters and then try to pour it in, you never actually know how much goes into your round bottom flask. So we want higher precision then. What we're going to do is measure actually how much goes into the round bottom. So we're going to put approximately 2 milliliters into here. That's not quite 2. We might go just a tiny bit over, but we might just stay a little bit under.
Having contrast issues.
Okay, we're at about 2 milliliters right there.
Okay.
Everybody see? So now we're going to weigh this again. There it goes.
All right.
All right. Now what we will see when we add this, and we'll weigh it a third time, is that not all of the liquid will actually make it into our round bottom flask. So while we're here, let's weigh the final product container. We're going to put our final product on this watch glass. This is how we're going to measure our yield at the end. So I'm going to weigh it. And then we're going to move this over.
Okay. All right, write it down.
Okay, so this is for the end of the experiment. Our final product will end up on this watch glass. Okay. Now, let's move over to this hood, and we're going to switch cameras. What we have to do first is add some sulfuric acid to some nitric acid in our round bottom setup. I have pre-made the setup. I'll go through greasing the joints in a second. Okay, we're at this setup. I brought the bromobenzene over. We're going to actually add him last, so I'm going to set him to the side up front. We have our apparatus that we're going to do the reflux in. I haven't greased any of the joints. I'll show you that in a second. What I want to do is mix the 2 key reagents, the concentrated nitric acid and the concentrated sulfuric acid together. If you've watched the video on what sulfuric acid does to sugar, it's going to do the exact same thing to the nitric acid. And because the reaction of dehydrating is so exothermic, we have to start by adding the 2 reagents together in the ice bath. So I have the ice bath now here. We're going to first, I have 6 milliliters of concentrated nitric acid. I'll show you the bottle it came from. You see that? Okay. We're going to pour that in and let it cool off first.
Can you turn the beaker?
And you're not going to be able to see much through the double glass of the ice bath, but there's a little pool of nitric acid in the bottom of the round bottom flask. Okay, now we have the concentrated sulfuric acid. That's this guy. We poured out about 15 milliliters. We're supposed to slowly add it so it doesn't become carried away. And so it suggests to add it drop-wise. We're going to try that, and we're going to watch to see if anything takes off inside. Seems to be holding pretty steady. And as long as it stays cold, we should be able to stop the reaction from taking off until we want it to. So I'm kind of swirling the sulfuric acid around. We're going to do a gentle swirl of the liquids. Very good. I've added about 5 milliliters so far. Okay, just stay nice and cold there. Okay. Sadly, I'm wearing gloves today. Professor Ormore made me.
Safety first.
He's worried because both of these reagents will instantly react with your skin. It's really cool what they will do to you. Which
Doesn't
is,
feel good.
you know, it burns, it itches, it sometimes does bubbling and blistering. There's a lot of cool things that these guys can do. What's also interesting is this is a lab that spilled all over my clothes one day and completely dissolved my shoes away.
We had a student at the North Vegas lab get concentrated nitric all over his shirt, and the safety people came and made him take his shirt off in the back room and wash off under the shower.
Right.
It was pretty scary.
We had a colleague in my lab at grad school get completely covered in concentrated boiling hot sulfuric acid. The blisters, we threw that person immediately underneath the shower, and they still had blisters all over their skin, especially on their face. So again, these guys react way faster when they're hot than when they're cold. Please refer to the sugar experiment with sulfuric acid, and you'll see just how exothermic this can become. And so that's why we're extra careful today. We're almost done adding the sulfuric acid.
Do we get any color change when you mix them?
You shouldn't. If you do, you've added them a little too fast and they became a little bit warm. It all depends on temperature. Okay. The final squirts of sulfuric acid. We're just about there. So in this reaction, the sulfuric acid actually has two roles to play. One is obviously he's the proton donor to activate the nitric acid, but another cool property is he's also a desiccator, which is he sucks the water out of the system, which is literally what he does in that sugar demo. He sucks the water right out of the sugar. Okay, we have carefully added the two chemical reagents. We're now going to add the bromobenzene that we weighed earlier. As I said before, some of it's going to be stuck on the graduate cylinder and on the dropper. That's why we weighed them all together. We're going to take one more weight to see how much of our starting material actually enters into this round bottom. So we're going to very carefully drop this one in. And it's going well. I don't see any color changes. This is all good. Okay. So, okay. We've added as much bromobenzene as we can. Okay, here's the graduate cylinder that had the bromobenzene in. We added what we could. We're now going to weigh this. And whatever the difference is between the full and this will be the mass of bromobenzene that actually went in the flask. It'll be the mass of bromobenzene you need in your calculations for your theoretical yield.
There you go.
Okay, now that we've weighed our bromobenzene and we know exactly how much is in there, we are going to grease all our joints. This is our first lab greasing this semester. I just want to make a comment on the proper way to grease. And what you do is you use a minimum amount of grease, and then when you put it in, you spin it. So I'm going to demonstrate first with the stopper that goes on the top. Tiny amount of grease, just a little bit. Can you guys all see that? I don't know if the contrast helps or not. When you put it into the stopper, when you spin it around, it should make a clear circle all the way around, which means we have an airtight seal. And we need airtight seals today, or your solvent will go around. So I'm going to do the same with this joint. I'm going to spin it all the way around, make it a nice airtight seal. So airtight seal here, airtight seal here. We are now setting up a reflux condenser. You guys should know that water always goes in the bottom and out the top. Another joint needs a tiny bit of grease. And grease just the top with just a tiny amount. That's plenty. And then the same thing, spin it around. Now because the pipes are in the way, I'll just go back and forth several times. And I should have a nice clear joint there too. Okay, the last piece we're going to grease is actually this adapter. We've hooked it up to a hose that goes over to this funnel, and in the solution we're going to put in some sodium hydroxide. What will happen during this reaction is the brown gas, nitrogen dioxide, will come off, and we want to quench it over in that beaker. So one more greasing joint. This will be our last one. Just a tiny bit of grease again. Everybody see how I just put a tiny amount on there? We're going to spin it around, back and forth until it's clear all the way around the entire joint. Okay, I have created airtight grease joints, but I want one. I'm going to add a special clamp right here to make sure this part doesn't come apart. Okay, the next step is to turn the water on. So watch here. I'm going to slowly add water, and we need it to run continuously, cold water from the tap. So it's running through. I'm going to show you this from behind. We're draining. That's a pretty good rate. We're going to keep that going down the drain. I can now take away the ice bath. And we're going to now place a round bottom flask as soon as I dry the water off. It came out of the ice water. Okay. So this is called a thermal well. This one's specifically designed to fit perfectly around a 100 milliliter round bottom flask. Okay. So I'm raising the thermal well so it goes up around the round bottom flask. Normally we would add a boiling stone. We now have some boiling stones. We only need one or two. And sure enough, in gloves I get about 20.
Don't blame the gloves for everything.
I'm blaming the gloves for everything today. Okay, I haven't turned the heat on yet. I'm going to reseal that joint. I'm going to set the entire apparatus down on the side. Very good. I'm going to find if I can get one of these boiling stones. There went one, there went two. That's plenty. Okay, reseal all the joints. Again, we need to have airtight seals on this slab. That's imperative. Okay, water running, joints sealed. Only thing left is to pour some sodium hydroxide over the funnel area. So we have some 10% sodium hydroxide. We're going to pour it over the top of this funnel so that the bubbling has to go through that. Actually, we're going to use it all. And it's time to crank this to high. So this is the rheostat that controls the thermal well. We'll turn it on. What we're going to be waiting to see is once this starts to heat up, that brown gas will form. We're going to let the reaction run until the brown gas is all gone. That'll basically tell us our reaction is over, and then we can go to the quench step. Last, we're going to preheat some ethanol because that's our recrystallization solvent, and we're going to need it to help clean out the glassware. So what I'm going to do is I'm going to warm up about 50 milliliters. I like to have my dropper in there, and we're going to raise the temperature to about 100 degrees because we just want it warm. pure ethanol, which is what this is. Boils around 92 here in Las Vegas. So 100 degrees should be barely boiling.
Denatured?
It should be denatured. It's not drinkable.
If the denatured alcohol means they added some methanol to it, so you won't drink it.
Just a little bit.
Drinking methanol is very bad.
So, cut. We're now, as you can see, we're going to watch the brown gas. It looks like our brown gas is all gone, so we're now ready to stop the reaction and quench it. The first thing I need to do is take away the heat. So I'm going to literally lower the thermal well away, and when I can, just drop it to the back. And that'll allow the finals of the liquid to stop dripping and go back in. Okay. Now, the quench step involves basically just diluting the strong acids that are inside the mixture. We're going to use about 50 grams worth of ice. I basically filled it up just to need something dark just to show you this. So I'm going to put this behind so you can kind of see. But I filled up the ice to just below the 100 line. That should give me plenty of ice for quenching purposes. I'm going to gently turn up this reflux. It hasn't started boiling yet. And we're going to need it boiling in a minute. Okay, so this is our recrystallization solvent. I'm going to leave that there, and we're going to quench the reaction. So if it looks like it's cooled off and it's stopped dripping inside, we then can break this first joint right here. Very carefully, I'm breaking that joint. Now, some of our product is possibly in here. We're going to do a rinse, so I'm going to set this gently down. And our first rinse will be water. Then we're going to come back later and do a second rinse when we start recrystallizing. But let's first quench this reaction. So, because this is so hot, I'm actually going to hold on to the flask using the clamp. And now watch what happens inside. As I pour in the hot mixture, you see it's immediately making a fizzing noise. It's melting away my ice as the sulfuric acid, the nitric acid become diluted, and it looks like we're actually starting to form product on the top. You guys can see that's kind of a yellow thick thing. That is actually our final product. Looks pretty good. So we're going to do one rinse of all our glassware with pure water, and then we'll save it later. And what's nice is we're just removing the acids at this stage, so a little extra water doesn't hurt. I'm going to set that to the side. Now for this big apparatus, I'm actually just going to pull the top joint off, and I'm going to rinse straight through the entire condenser. Okay, so right into my round bottom. And that way, hopefully I will be able to remove any acid type molecules at that stage. So, and now I'm going to pull this joint off and do a rinse down through here. Okay. All right, now to re-say what I've already said, there's a possibility of some of our products stuck in this glassware. We will extract that later when we go to the recrystallization steps. So again, I'm going to set this to the side and be very careful with it. Okay, so what I've done in here is I basically made a soup of our product in an aqueous environment. Our product really doesn't like water very well, and if the product doesn't precipitate, we're going to stir it until it gums up. It's almost like making butter. Usually I call this the butter churning lab, where you beat on the organics together until they all clump up. Okay, so I'm going to try to show you the bottom just a little bit. You see there's some solids starting to form on the bottom. We need it to clump up as much of the material out of the liquid as possible. And so I'm just going to stir vigorously, just like I would if I was churning butter in the old days. And basically I'm beating the organic molecules together. That's how a butter churn basically worked. Is you would beat on it long enough until the organic materials coalesce together in a semi-solid. You'll also notice as I beat on it that the solution actually seems to become a little clearer. That's another good sign. That's a sign that the organics are actually clumping up. So I'm getting a nice layer of organics on the bottom. The solution is becoming a little less cloudy. Okay. I'm now going to ice bath that and do the first crude filtration. Okay. As you can see, most of my product's clumped up. It's clumped up even on the strain rod. That's excellent. That's what we want to see. I'm going to ice it for just a minute. And while it's icing in the ice bath, we're going to prepare our Buchner funnel. Our Buchner funnel works by having little holes. We're going to put a piece of filter paper on the top of it to stop anything of major size from going through the holes. Then we'll turn on the house vacuum, and we're going to wet the paper down to make it nice and tightly bound. And I don't know if you can see from where you're at. Maybe I'll disconnect just for a moment to illustrate this principle. But as soon as I pour in some water, I have some water from here. I'm on camera.
Okay.
The water gets sucked immediately right through. And that's the nice thing about a nice suction filtration. It'll be a really fast filtration we're going to do right now. Now the object is to remove any acids and to capture as much of the organics as we can. The other thing is we're going to reuse this beaker to recrystallize in, so we do not have to get all the solid out. The only thing we have to remove is all the acid. So what I'm going to do now is just slowly pour this liquid over the top of our filter paper. Okay, since we're removing the acid, I'm going to do one rinse of everything with water. And I'll pour that over the top. Okay, and hopefully most of our product's still inside here. Looks like we have a fair amount of product. Everybody see that? This is going to be a good day so far. Okay, we're going to wait for this to stop dripping. And it has stopped dripping. A couple more drips. Okay, it has stopped dripping. I can now turn the suction off. I'm going to show you what's inside of our Buchner funnel right now. If I can tip it over just enough without spilling. You see, some of our product was captured by there. We're going to transfer that back into here. And then we're going to take a scoopula or a spatula and carefully lift up the paper. And I'm going to show you the paper up close and personal. And you see, if you look carefully at the paper, you see it's covered with yellow product as well. I'm going to set that just on the edge of our first funnel. And then there's a few more powders in here. I'm going to try to maximize our yield. So I want all that yellow solid back into the original beaker. Okay. Now, this is our crude product. The procedures say to take a melting point of the crude. Are we still going to do that, Professor?
Yeah, take a melting point sample, we'll do them together.
Okay, so I'm going to take a little sample now, and hopefully it'll not be too gooey. Which is really bad.
It's for sure going to be back if it's wet still, too.
Yeah, it's not going to be a good sample.
I usually have them dry it for a few minutes to get the
Okay,
crude.
I'm going to take this and dry it then.
Okay.
Because I normally don't do a crude because it's always wet.
Yeah, just let it.
I'm going to let the vacuum just suck on it for a while. And then there's some crystals on the corner. So I'm going to leave the vacuum going. And I'm going to take a little sample of this out. We're going to lose a little bit of our yield, guys. There's a nice looking sample of product right there. I'm going to put it right on the top of this. Put my melting point tube next to it to remind me to take a melting point of that later. Okay. So that's just going to be sitting there drying. The rest of our product we're going to recrystallize. The secret to recrystallization is the following rules. You always want the minimum solvent possible to completely dissolve everything. Now, remember I said some of our product looked like it was stuck in here? I want you to look, there's some yellow stuff here. I have some boiling ethanol, which I started boiling earlier. I'm going to do a little rinse. And you see we got a nice yellow color. I don't want those boiling stones, but I want any organics. Okay, so that, another little rinse. And my glassware almost has no yellow color anymore. That's a good sign. Okay, so I've removed the product that was stuck to that glassware. I'm going to do the same now to this one. Same exact thing, except we're going to start at the top and do a little rinse first for the condenser. And I'm going to do another little rinse. Alright, that should take care of the condenser. That means I can take this clamp off. Set that just gently like that. And look carefully. So I'm looking to see if there's any yellow left on there, and it looks pretty clean. So now that leaves the Claisen adapter. The last one to rinse off. Okay, so we examine the Claisen adapter. Do we have all the yellow off? That one's done. Okay, so we have more or less transferred as much as we could into the original flask. We are now going to recrystallize it by just boiling the solvent. I'm going to add a little extra solvent to try to dissolve the edges. Now, one of the other catches about recrystallization is if you use too much solvent, you'll lose part of your yield. So you want just enough to dissolve everything, but not so much that you lose your product in the final filtration. One last thing I need to rinse off is the stirring rod. You want that out of there. So you see the stirring rod is still sticking. Let's get all our product right off that stirring rod. Come on, stirring rod, let go. There it goes. Little bump there. So we have a nice clean stirring rod. Okay. Let's see if we can make this boil now and go completely clear. Should be a nice yellow clear color. Set that down. And that'll usually take a few minutes. And now I'm going to go back and check on our crude. Has it dried long enough? Can't dry with acetone or it will. I think we have it dry enough in here to get a melting point. I'm going to try. Okay, it looks like I have enough of a crude sample that if we bounce it to the bottom, we should be able to obtain a melting point. That said, I want to increase my overall yield. Yeah, I think that's enough for a melting point. Okay, so I have the product in here. We're going to send this to the melting point apparatus a little bit later. And so while that's trying to dissolve, I'm going to transfer again, anything that's in here. Oh, there's still a little bit inside. I'm going to try to get it in here. Again, the whole goal is maximum yield, highest purity. So, I'm going to show you one more cool trick you can do. No, that wasn't it. Okay, normally, when the paper is wet, you can get it to stick to the glass. There we go. That's what I was hoping for. Okay, so I made the filter paper stick to the glass. And I'm going to try to squirt off as much of the yellow as will come out easily. So, okay. That looks like enough of that. Oh, okay. I'm going to show you this just to get up close. The orange we don't want, but it looks like I got most of the yellow off, but I missed some of it there. We're just going to call that a little bit of lost yield. Maybe not very much. Might be a few milligrams. Okay. Our liquid here looks like it's about to boil. And to see if we have enough solvent, I'll show you a trick. We're going to put a watch glass on top, a little bit of ice, and if it boils and recondenses, all of the edges should be dissolved down into the bottom. And that's what we're going to do right now. You see how it's boiling? And there went one section of the edges. Let's spin it around slowly. We're looking for anything stuck on the sides of the beaker, because while it's boiling, it'll dissolve away while we're refluxing the liquid. Oh, it's looking pretty good.
I want to mention that you're boiling ethanol, right?
Yes.
Yeah, so if you ever have to boil ethanol in the lab, you should always keep it covered or on a fume hood, because you can get drunk off the vapors.
Yep. True that, which is a sad truth for some. Okay. So, as I go around, I'm going to go around one more time, and you guys watch, see if you see any solids still stuck on the sides. I'm not seeing any. Except maybe right there. Or those might be on the outside. Okay. It looks like we've done enough. The liquid is basically clear. So the other key about recrystallization is be very patient cooling it off. If you cool it off too fast, the products, when the crystals form, will actually trap products in. And I can see it's already starting to form crystals on the bottom. I don't know if I can tip it. You want to tip the camera?
Yeah, you turn it so the text is that way.
Okay.
Hit cloudy.
Yeah, there's a little bit of crystals forming. Once you have the first crystals, the other crystals should grow on them. And I can see them in a pile when I do a swirl. Can't see it when I take the blue away though. Okay, so I'm going to try to show you up close. But you see there's a little pile of crystals starting to form in the bottom. Hopefully you can see that. And so we're going to just let that cool. It needs to come down to room temperature. And before we ice it, the entire beaker should fill up with crystals. Then you're going to do we'll do a final icing to maximize our yield in this solvent. So for now, we're just cooling. And while that's cooling, I'm going to prepare the second filtration. So our final filtration, we need to clean this up. I'm going to remove all the acid water that's in here and then rinse it out with acetone, because our final filtration will be organic, and the organics need to be discarded in the organic waste. It does this thing sometimes where it emulsifies instead of crystallizes. Okay guys, we've been recrystallizing. You'll see we got a nice pile of crystals right now floating on the bottom. We feel the temperature, it feels more or less to room temperature. We're now going to ice it for 5 more minutes and do our final filtration after 5 minutes. Okay, we've iced our final product. We have it nice clumped up here on the bottom. The final filtration needs to be done in ethanol, so over here I prepared some ice cold ethanol, also in an ice bath. We're going to first wet down the paper with ice cold ethanol. I wetted, the suction's on, check. Wet the paper down, check. Suck the ethanol through really fast. Okay, now we're going to try to transfer all of this liquid in one go and capture the solid on the middle of the filter paper. If there's any left behind, we're going to use ice cold ethanol, but remember, the more ethanol I use, the more the product will be lost. So we're in a catch-22. We want to transfer it all. We don't want to lose anything. And since it all stuck to the top, I'm going, there it goes. Come out. I'm about to get my glass stirring rod.
You're just hanging out upside down.
Okay, so some of it's stuck to the bottom. I was afraid of that. I don't want to lose too much product, but I want my product for the final weight. Okay, so most of it came out, but not all of it. That's what the ethanol's for. We're going to squirt it, swirl it, pour it. How do we do on that one? We got about 80%. We'll do it one more time. Squirt, squirt. Maybe 2 more times. Now, I'm running out of ethanol. That's the reason I have ethanol. Let's pour some more ethanol. Okay. So this will be my final one, I hope. Pour it over the top. Okay. A little bit of product's lost. Can't quite transfer it all. But if I look down at my separatory funnel, that looks really good.
Let me get a nice view of that.
And we're going to do 1 rinse now of ethanol across the top. And hopefully that'll remove any of the impurities that may have been created, which you learn in the pre-lab is the 2 initial products can be our impurities.
Yeah, sometimes if you get a lot of the other products, your solution down here will be really bright orange.
Okay, now take a picture of the solution. You see that yellow color? Technically speaking, if we condensed it down, we could make more crystals out of the ethanol here, but we're not going to do that today. Our yield will be just whatever we obtain from up here. So now that we've done the rinse and it's ethanol, it's going to take 15 minutes of air drying time. We're going to stop recording and just let the vacuum go. Okay, we have been drying our product for about 15 minutes. You'll notice 2 things. One, our product is drier, but remember what I said about re-dissolving some of the solid? About half of the liquid evaporated away, and some of our lost product is now crystallized on the bottom. As I said, if we wanted to, we go back and try to collect that, but we're not going to.
Make sure you mention sources of loss of your product in your report.
Make sure when you're explaining the percent losses, you know one of them's right there. That always happens. Remember what I said earlier in the lab, the more ethanol, the more of your product ends up down in this funnel. Now, our product here is nice and dry and a nice light yellow solid. We're going to put it on our pre-weighed beaker that we pre-weighed at the very beginning. So it's looking really pretty. It's nice and white. I'm going to gently knock off any of the powder that was on the paper. We're going to discard the paper because you never weigh paper because liquid impurities always get stuck inside the paper. Check inside of here. There's a little bit of crystals right there. So once we are confident we've obtained as much product as we can, and again, I know we've lost some over here in the sidearm flask. We are now going to do our final weighing for today. And then I'll take a melting point of this final product. Okay. So moving over to the scales. We pre-weighed this watch glass. We now have our product on it. And if I drop it, it's all because of the gloves.
Yeah.
I couldn't feel for sure. Okay, so when that's right there.
There we go. Yeah, 55.553.
38.
Okay.
The last thing we need is a small sample for the melting point. We'll just use this. The other beauty of a watch glass, gives us a nice surface to put our product in. Yep. And our product is fairly dry. We just need to bounce it. So where did the bounce tube go?
Oh, over here. So we use the glass tube to bounce it. It helps pack the tube. Here.
So we're going to put the glass on the top, and as we let go, you'll see that the melting point tube bounces, and it condenses the solid on the bottom.
Do it again so we can get that.
Ready?
You can see it bouncing in there.
There we go. And we now have a sample that's ready for a melting point. Okay. Let's move over to the melting point apparatus.
I got it. Okay, everybody, I'm getting just set up here to get the melting point of the crude and the purified product. On the left, I went ahead and put the left one here is the crude. The right one here is the pure. I set my starting temp to be 40, and then the ramp rate, is typically 5 degrees C per minute. And the stop temp doesn't matter. It's going to melt well before the stop temp. I think it's like 230. So yeah, well before then it's going to melt. But enjoy the show.